For the first time, we've got something that feels a bit like general intelligence. It's a super powerful tool to be using. If you're interacting with these things, it's like genius, 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 genius. I completely trust you, genius, 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 5-year-old. Oh my God, I just pushed out that figure out in there that a 5-year-old wouldn't have made. So it's actually a pretty dangerous thing. I wouldn't want anybody to listen to this and think, oh great, the AI fairy is going to come in, I'll turn it loose on my company and it's going to connect up my knowledge graph, and then suddenly, I'll have an agentic system that knows all about my business. It's not going to happen that way. There's a load of blood and sweat that needs to be put in. My consistent message, as I say, over the last 10 years is people need to be taking that very seriously. And the best time to do it was 10 years ago. The next best time to do it is right now.
Hi, hello, and welcome to the Capital Markets FinTech Forum podcast. I'm David Jones. I'm a co-founder and the CTO of ipushpull. This week, I'm very pleased to be speaking to Tony Seale. He's a technologist with extensive capital markets experience, but perhaps best known as the knowledge graph guy. Thanks very much for joining us, Tony.
Yeah, it's a pleasure to be here. Thank you for having me.
Great, thank you. So where did that title come from? You're very well known on LinkedIn. You've got a big following as the knowledge graph guy. So how did that happen?
The actual idea for the name knowledge graph guy was my wife's idea. Actually, she said, well, everyone calls you that knowledge graph guy, so why don't you just own it? And basically, for the last over a decade now, I've just had a solid mission to be talking about knowledge graphs and raising the architecture as like being an important one. So I'm going to sort of pat myself on the back in that I saw the AI wave coming in, and my strong instinct at that point was it's all very well having powerful AI, but unless an organization has got its data infrastructure sorted out, you're not really going to be able to use that AI in an effective way. And at that point, I'm kind of looking at it and thinking it's an enormous, a huge job for like a large organization to do that. So I was sort of like calling out 10 years ago or something, come on people, we need to start getting the information organized in preparation for what is coming. Some people listen to me a little bit, I think, so hopefully they're somewhat ahead of the curve now, but like there's obviously an enormous amount of work still to do here for a lot of organizations.
Okay, so that's very forward looking. So what kind of organizations were you working for, and how did you manage to persuade them to invest in this technology at that time?
Investment banks that I kind of cut my teeth on this stuff with. The first one was Deutsche Bank, actually, where I've kind of spent my entire career doing data integration, and I was doing an OLAP cube. Any of your listeners remember those? We're kind of getting like the return of the OLAP cube now in YAML format with OSI. So I was working on an OLAP cube and doing the pre-ingestion layer for it, the ETL layer, and I just thought there must be a better way than this. I've kind of doing the same thing again and again, and there simply must be a better way. And I'd watched Tim Berners-Lee's TED Talk on linked data, and I thought, I'm just going to kick the tires and see whether this will go anywhere. It probably won't, but I'll just, I'll just see where it goes. Cut the long story short, but basically, before I know it, I've kind of linked together the whole FX trade population, and then we've sort of solved some audit point which had been outstanding, and how it was a very big deal around double binary options. And then I'm going around on the trading floor, working with the traders, doing these systems. So like the whole journey has really sort of escalated there. And then at the point where I left UBS for UBS, so I left Deutsche Bank and then went and architected the UBS knowledge graph with a team of great people there. And there we were kind of doing like a kind of more of a top-down strategic piece. We're going to put the knowledge graph over the top of UBS, and that was like another great experience. But at that point, I thought, I've sort of spent all of this time trying to convince people, and I used to do these, like little hand-drawn drawings to try to explain these complicated ideas. And I thought, well, I'm just going to start pushing that out onto LinkedIn to kind of make the message broader. And that's like returning back to your original question, then that's kind of where the knowledge graph guy thing came from.
Great, and the rest is history. Can we start just at the very beginning? I think a lot of our listeners are familiar with relational databases, but what is a knowledge graph? How do you use it to organize data, and what benefits does it bring over entities and relations?
Yeah, so I mean, the interesting thing is relational databases, they don't actually treat the relationships between things perhaps as importantly as they should do. Essentially, when we're they're amazing, and I use them the whole time, or integrate with them at least, but whenever we're kind of making a decision about how we're going to model something with a relational database, we have to kind of put it into this rectangular box. So it's like we're taking a concept. It could be very, very complicated. It could be very nuanced. And we have to dumb all of that down and say, like, how are we going to stick it into this rectangular box? Imagine this kind of incredible, complicated business problem. And we're just going to kind of say, okay, that is incredibly complicated and everything, but I'm just going to kind of put it into this box. So then I have another box over here, and I'll maybe draw a line between those two boxes. So I've got this kind of connection. So that's relational databases. And then and it's based upon set theory, and it's super powerful, and it's never going away. It's a really useful thing. But sometimes you want to keep some of that nuance, and you want to keep some of that complexity, because actually the question is really important to you, and you don't want to dumb it down to this level. The way that a kind of the graph approach to this is less box shaped, and it's more about the relationships between things. So I'll have a given entity. You can think like the classic example is like your sort of Facebook network or something like that, where you've got friends and then they've got friends. But the relationship could not be friends. You could create a more complicated graph where you could say, well, this person lives at this house, and then this house is on this street. So there's kind of no end to what we can encode within one of these knowledge graph structures. I guess the thing to understand about it is twofold. Firstly, the relationships become as important as the entities, so the connections between things. And the more time that you spend thinking about data, the more you will come to realize that data is all about those relationships between things. That it was that line in the original Tim Berners-Lee thing that really struck with me, and I've been thinking about it ever since. It's like data is always contextualized. The meaning comes from how a given piece of information is connected into other pieces of information. So there's a very real sense in which this is a more powerful structure for expressing complexity.
And I mean, people are familiar with the traditional database providers like Oracle and Postgres and so on. So and also using language like SQL to interrogate relational databases. So what are the kind of equivalents in the graph world?
Yeah, there's lots of different flavors of graphs now. Typically, they sort of break down into two main streams of, like, people talk about labeled property graphs and then triple stores. But in reality, the landscape is more complicated and nuanced than that. And then there are query languages over the top of those. So again, for triple stores, there's one called Sparkle, and then for labeled property graphs, like Cypher is Open Cypher is coming out as a standard. That we do have a new graph query language, which as well is sort of coming up over the top. Generally, quite a lot is made of these sort of different flavors of graph databases, and quite often that's somewhat manufactured, I feel, by the kind of sales and marketing teams and stuff like that, where it's like, oh no, you must have this one because it's got such and such a thing. In reality, as practitioners, we'll flip between these different formats of graph representation structure, and different ones are good for different things. And one of my little hobby horses actually is that for a given organization, you shouldn't come at the problem thinking about it as a kind of database. So don't come about it thinking about my knowledge graph is a database. Think a bit more like a kind of architecture for your organization, and to a certain extent, like people have kind of like memed on this idea of context graph, which is just kind of another relabeling of the same thing. But it's more kind of powerful to imagine, well, I have all of this information within my company. It's very rich. Ultimately, it's interconnected, but it's not interconnected at the moment because it's siloed into these kind of like separate systems. And what I need to do in order to be ready for the age of AI is I need all of these systems talking to each other in a network, a distributed network that will, in an idealized state, represent all of the information that is within my organization, and all of it is connected together. And if you approach thinking about your knowledge graph from that perspective first, and the database perspective second, I think you'll be doing yourself a lot of favors. Which is not saying that graph databases are not necessarily. A lot of my friends in the community would be very annoyed with me for saying that, and I'm not saying that at all. But they shouldn't be, from an architecture perspective, the first thing in your mind. They should be, well, essentially, I want to connect my information together into a graph. I want to organize it by an ontology, which we should probably talk about as well at some point. Then when I come to query it, I'm going to need it into some kind of queryable data structure, graph data structure. Is it a graph database? Well, maybe it is. Maybe it isn't even actually a graph database. It's like a sort of traditional SQL database that I've repurposed for this task.
So yes, well, let's drill down into the ontology point. This is a term that's been thrown around a lot.
It's kind of like got a mystical edge to it now, right?
Yes, exactly.
We'll try and let's see if we can demystify it. Like, so the term ontology itself comes from philosophy, actually, and like way back to Aristotle, and it's about like your kind of model of the world, your ontological view, your how you're seeing the reality, basically. But in terms of how we use it now, when people are talking about ontology in relation to computer science, then it's a formal ontology. So, okay, then what does that mean? Well, perhaps one way of seeing it is a graph. So as we talked about graphs before, but now what this graph is going to focus on is just the concepts themselves. So like there are the instances, like you and I are instances of people. And then there's the concept of person. So in some ways you could kind of see it like the schema of a database, or the column part in your Excel spreadsheet, or other times like people talk about it as being like metadata. But when you talk about it like that, that's fine. But you've got to understand this is like a schema on steroids, because actually a lot of the concepts which were used in both AI and like object-oriented programming and stuff, they have migrated into this. So I can have inheritance structures in there. I can have inheritance structures within the properties. It's itself like a graph relationship. So in many ways, it's much closer, and necessarily so, to the semantics of how a given domain expert would be talking about their area. And that's kind of the essence of what we're trying to do with the ontology. We're trying to take tacit tribal knowledge, which is in a domain expert's head, and then so that's their kind of worldview. They've got like a worldview of a specific aspect, be that like of the law, or of the sales process, or of how a given widget in a factory works, or whatever, you name it. Like there's all these kind of like domain specialities, and these are at the moment sort of very fuzzy, somewhat recorded into like maybe some documentation, but largely, as I say, like tribal knowledge just inside the expert's head. And the name of the game of the ontology is to try to encode that into like a formalism. So we're going to try to put that, and again, because we're going to be using this graph structure, we're not like trying to stuff it into like just a rectangular shaped box. We've got a lot more freedom. So it's a lot closer to how you would probably think about the problem. Like if you got in front of a whiteboard and you were trying to describe this particular area, you draw circles and you say, well, we've got people, and people have these, and then so you would kind of like at a conceptual level be drawing out what is effectively a graph. And with the ontology, that's what we do, and we store that conceptual model down. And when we do, what we want to do is we want to make that model logically consistent. So that again is like kind of going back to like very old and again philosophy based, or again all the way back to Aristotle actually, of like logic. We want when we're talking about this ontology being formal, we want it to be logically consistent. We want it to be logically formal. So that's what we're specifying.
I noticed in your background you studied philosophy at university, and you referred to it a few times during this conversation. So it sounds like that background really helps you think about the concepts that are required for this job.
That's right. I didn't actually do computer science at university, but then kind of trained myself to be a computer scientist when I came out, and I suddenly discovered, I love computers. I would never have thought about that. My wife was very disappointed. Actually, she thought I was going to be like an artist or something, and I ended up being a nerdy computer program.
Pays the bills, doesn't it?
Yeah. So, but no, the philosophy is useful. I found it very interesting. Before I was doing knowledge graphs, and I was just a general programmer. I was very into object-oriented programming, which to me back at that point, I was thinking, well, this is like Plato basically. So I've always done that, and then it's been interesting to think then about. I view the semantic web as closer to Aristotle, and so I definitely draw upon the philosophy.
The Greeks were the first developers, though.
Yeah.
Obviously, knowledge graphs have become being really important in the world of AI, particularly with being used with large language models. So, can you explain a little bit about what they add to any process that you're trying to automate using AI? How can a knowledge graph improve what you're doing?
There's sort of two things to say on this, and I kind of I talk about this in terms of like what I call like a neural symbolic loop. So basically, the neural side is like the large language model. So a large language model it's at the end of the day, it too is a network. It's a neural network. Network is a name for graph. So basically what's happening there? Well, like a huge amount of data has been pumped in at the other end of that. And then we have these like artificial neurons, and each one of them is connected together with an edge. So we've got the nodes and we've got the edges. Through the back propagation process, then what you're doing is you're learning the weights between those edges to be able to then kind of predict out of the back end. So we've got kind of a network structure there. And I think at some deep level, there's something about the network structure which is like a learning structure. It's just like graphs, like different structures have different properties to them, and there's something about the network structure in a way that you can't necessarily, I can't put my finger on, but there's something about that structure which at a deep level I think is a learning structure. What happens is at the moment we're trying to combine that graph-shaped learning structure of the neural network with like a boxy shaped data structure of the tables, which are in here. And the interesting thing with knowledge graphs is if we say, well, what about if we make the data more in the same shape as the, if we put the data into a network shape as well. So we put the data into a graph, and suddenly we have this much more expressive structure that is a lot closer on the data side to what the, to the structure of the, and then we can learn in the data as well. So, and that's interesting and very important. So that's at like a super high level, I guess, of what's going on. But if we then talk about the neural symbolic loop, or why were knowledge graphs not super popular before, while I was banging the drum for them, and then others doing it 10 years before me as well. And the big tech companies like Google and stuff had knowledge graphs. There was some within the pharmaceuticals, within the R&D departments. Maybe like a few of us were like pushing the boundary within finance to start bringing them up, but they were not like hugely popular because they're very hard to build. They require a lot of expertise. They're unfamiliar to everybody that's kind of grown up with the relational structure. They're more complicated when you come to doing the ontology piece. That's like a huge amount of human effort to do there. So one of the clear ways that large language models have changed this equation is that you can point the large language model back at that process of like working out what the knowledge graph and what it's to look at. So like this huge amount of like effort that had to go into doing it doesn't go away. I wouldn't want anybody to listen to this and think, oh great, the AI fairy is going to come in and it's basically I'll turn it loose on my company and it's going to connect up my knowledge graph, and then suddenly, I'll have an agentic system that knows all about my business. It's not going to happen that way. There's a load of blood and sweat that needs to be put in, and my consistent message, as I say, over the last 10 years, is people need to be taking that very seriously. And the best time to do it was 10 years ago. The next best time to do it is right now. So if anyone's listening to this and thinking about it, then get on with this job. But then I think the days of convincing people that this is a necessary thing to do are done. Like this, every C-suite, this is the discussion in every boardroom across the world now, where they're like, oh, well, we built out this BI system. It's really good. It worked well. Oh my God, it's not suitable for working with like an agentic future. What on earth are we going to do? So that's where everyone is kind of like scrambling now for the knowledge graph. Semantics. So that's the first part. It makes the building of the thing easier. So it makes it a more tractable problem. Still works, but like you've maybe like taken 80% of the work out, which is a big thing. Makes it feasible not for just the big tech giants or the massive investment banks. It makes it feasible for a whole load more organizations. So that's on one side of it. But then it plays back out on the other side as well, because the thing about large language models were two things, maybe even three, about them, is essentially that they are based upon their training distribution. So their training distribution is absolutely massive. We the people put all of our information out onto the web. We connected it together with hyperlinks. That's been ingested into the large language models, along with a lot of other data as well now. And so they've got this absolutely massive training distribution. And while you're within something that they've been trained on, they're kind of at like a genius level almost now. Not quite genius level, but like extreme expert within that area. But what we say is that their intelligence is jagged, because if you fall out of one of these areas, so it's in genius mode because you're well within the distribution of the data. I now fall outside of that distribution of the data, even just like a little bit actually off to the side of it. And basically it drops from genius to sub 5-year-old in terms of the call that it's going to make. And that's actually super dangerous, because it's like, if you're interacting with these things, it's like genius, 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 genius. I completely trust you. Genius, 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 5-year-old. Oh my God, I just pushed out that figure out in there that a 5-year-old wouldn't have made. So it's actually a pretty dangerous thing. So what do knowledge graphs do for this? Well, knowledge graphs don't have that magic that you get on the neural side, where they can do poetry and, they can do this kind of like creative thinking.
Yes.
But like databases, you can rely upon them. So like once you've verified the result and you put it in there, and once you've kind of put the logic into your ontology and you've nailed that logic down, then you can rely upon that for giving you back accurate information. And then the other thing as well is, like, once you are inside a given organization, you're potentially out of the thing's distribution. That's not actually such a bad thing, because actually what is valuable about your organization is the things that you know that nobody else knows. Like the price of intelligence just dropped to the floor. That's anything within distribution. The worth of that has just dropped to like 0.001 cent. 0.1 cent, get a 0.001 cent or something like that, because anybody who's got a large language model is now going to be able to answer that question. So actually the information that your organization is holding that is out of distribution is the valuable information, but it's currently fragmented. It's not necessarily got the tribal knowledge associated with it. It's not in the right shape for a large language model to be using it. And you'll hear people kind of like, as I say, to kind of talk about agent memory and context graphs, as if this was a separate thing from knowledge graphs. It's not like that's just kind of marketing over the top. Essentially, the name of the game, we have the technology set in order to do this. The name of the game is to connect as much of a given organization together, to organize it by the very semantics of that business in a logical way using an ontology, to connect the ontology back into instances of the data, and then you plug the AI into that. And the way I say it is that you can think of it like a kind of road system. Like you go into your organization and you're going to build your highways, which are like the ontology is like your kind of motorway or highway that is going in there. Then you've got these various kind of arterial roads. They're all connected together. The AI agent is the intelligent thing, and you go ask it a question. It can't just go anywhere that it wants to. It's got to stay within the constraints of this road system that you've built. It's kind of giving you answers back. You make sure that it's not broken any of the kind of highway code rules of the road when it's doing so. So it's got it's got access to your internal information, and that's richly connected together. And B, we can validate that in a logically consistent symbolic. It's those two things together then that are kind of like this neural symbolic loop that I'm talking about. You turn the neural side back on trying to build out the graph. Once you've got the graph, you pass that back into the neural side in order to be able to answer questions.
We've seen some of the limitations of trying to use traditional databases to feed data into agentic systems. So we prototyped an agent which we gave access to a trade history, and we found it was very bad at actually inferring, being able to infer useful data from a large table of data. It would be able to answer questions about the start of the table or the end of the table. It kind of lost interest in the data in the middle. So is that an example of a use case where organizing the data as a knowledge graph would start to resolve some of those problems?
Yeah, I imagine so. I'd hasten to, like, the thing with this, like, in terms of the knowledge graph guys. So I guess I should say the last part of my journey was then about I left UBS and I've founded a consultancy helping organizations to kind of transform their data to build their knowledge graphs and transform their data into that shape. And whenever we're doing that, then the first thing that you have to do is you just have to evaluate against real benchmarks. So yes, probably, like we usually get the result, but I'm not going to turn around and say, yeah, the graph is definitely going to have worked in that solution. We would basically have to create the kind of evaluation harness around it. You'd chuck state of the art, what you could do with a large language model. And then it's like, okay, well, we now put this into a graph. We put some ontology in. What does that do for the numbers of the results? And you just kind of then keep twisting the knobs until you get a good result, which I don't know, like in 80% or something like that of cases you do, but not always. Not everything is a graph-shaped problem.
You said that all companies are either thinking about this already or should be. I mean, if somebody's listened to this podcast and hadn't started down this journey, what would you advise them to do?
Advise them to go and read some of my posts on LinkedIn. There's kind of some other authoritative sources that are out there as well. I would advise a healthy dose of skepticism, because suddenly now a lot of these terms like knowledge graphs, graph in general, ontology, they've gone from being a sort of very niche thing into something that basically dollar signs are flashing up on everybody's eyes. So, that what that inevitably is going to mean is like the marketing machine kind of comes in and there's, going to be there is already like a lot of kind of misinformation going around it. So, be careful that, when you're, to check the lineage, I guess, and the history of information that you're hearing when you're hearing about these subjects, and make sure that it's coming from an authoritative source. There's been 30 years worth of hard grind academic research on this stuff. I see an enormous amount of people kind of reinventing the wheel. It's the cognitive load of like understanding some of these concepts initially feels quite high. So maybe what I'll just do is I get the rough idea. I'll just create my own database table, and I'm just going to model an ontology in a database table, or I'll just blat something out in YAML or in JSON, maybe that, or then I don't have to kind of like worry about these things. You've got to have your view on the long term game of where this is going. So we're phase one was the agents basically ingested the web, so there was this network of structural network of information, all of that text all connected together. That was ingested and compressed into the agents. And then for the first time, we've got something that feels a bit like general intelligence. I know that there's a lot sort of debate, all of that stuff, but for anybody that's using it heavily, there is no debate. It's like it's a super powerful tool to be using, like revolutionary, just as it doesn't have to get any better than it is right now, and it's going to get way better. But even if it just stayed as it is right now, it's already like a revolutionary technology. And we're heading into phase 2, as I say, where then organizations are like, well, what do we do now that the price of intelligence has dropped like this? Oh, we've got to connect our context together. So, all right. And there's certain kind of fundamentals, which are almost like the fundamentals of physics, that you just don't get away from when you come doing this kind of data integration. And believe me, I've been at this, doing it in production in high stakes environments for a long time. So I've looked for every shortcut that you can possibly get. And so I know that there are these kind of like certain fundamentals that you're just going to end up having to reinvent. So like identifiers. Like if you're an organization of any size, you're going to need like a distributed way of doing unique identification. So if you want to kind of link things together, you have to nail that problem. You can look around for different ways of doing it. I mean, if you're a new company like a startup, it's maybe not such a big problem. But if you're an existing organization that's already got like a fair amount of organizational data, you're just not going to find a better way than a URL for doing your distributed identifier. So that's giving each item its own distributed identifier. And then ontology, you'll need you're going to have some kind of categorization system. You could do it not in a network. You could do it not in a graph, and there are attempts going on in there. And I don't want to be too puritanical about that, because they are part of the picture. It's not like black and white. It's this kind of gray thing, because we need to integrate with the relational structure that was already there. But is a relational structure on its own enough? No, it's not, because you can't do proper learning within that structure. You're going to need something more complicated over the top of it. And then finally, and this is kind of the part that nobody wants to say because there's no money in it, but you've got to do it upon open standards, because phase 2 we're in at the moment. We don't know how long it's going to take. We don't know how many are going to make it out. Even phase 2 of consolidating and working out your ontological core, connecting your information together. How many businesses come out the other side of this? We don't know. But that's still only phase 2. Phase 3 is going to be the agentic web, where data within organizations is shared across organizational boundaries upon these like open data markets. Then you've kind of got you've got your own internal agents which are protecting the integrity of your boundary and your system. But you can't work in isolation and cut yourself off from markets. You can't just have your own kind of proprietary ontologies and stuff like that. You're going to have to integrate with industry-wide ontologies, and you're going to have to be able to, your identifiers will have to be able to go across organizational boundaries where that makes sense. I mean, so much of it is not worked out, but it's going to happen so fast that it doesn't make sense to just be acting reactively here. It's like people say on like trader friends have said on the market, don't want to be just like on this signal. You want to be kind of looking at the bigger picture here. And if you just like step back and think about it logically, this only goes one way. We had the human web. We're going to get the agentic web. You do well to think about the implications of setting your organization up so that it's set up for the agentic web.
And that means very much thinking beyond just the boundaries of your own organization.
Yeah. I mean, right now, it's consolidating your data within. You need to learn how to do it within your organization, but you have to know that is not the end game of this. It's not like, as a CEO or CTO of your company, it's not like, oh, we built the BI thing, now we need to kind of get that into some kind of semantics and knowledge graph so that we can use agents here. Yeah, you have, yes, that's what you need to do, but then don't put yourself back into exactly the same boat in 3 years' time where you're like, oh gosh, we've just built something that's completely proprietary within this organization, and now we can't get out onto the agentic web and integrate with the external agentic marketplace that's kicking off.
Gosh, sounds like a very exciting future.
Yeah, exciting, and but it's, it's interesting. Like, some of us have, like, they call it like wirebraining or AI pilled or something, along these lines. So like a certain percentage of the population, myself included, like inside the knowledge graph guys is like a big knowledge graph. Obviously all our information is connected. Because we started out fresh, you're able to kind of realize the dream from the start. You're just working with agents. So basically I am and I have then kind of like a personal one as well. So like I'm just interfacing with these things a lot, and have been doing so for, I don't know, I'd say half a year, 3/4 of a year now. And it's interesting because I think there are, yes, the future is exciting, but there's all sorts of psychological implications that we haven't really thought through, about what it's going to be like, because it's not less work. It's not like sitting on the beach while your agent does this. It's actually, now suddenly your possibilities of what you can do are vastly expanded, and now you're spinning all of these plates that are going on. That's another thing I'd recommend to people, actually. They go and look out my original Embrace Complexity series. It was wrong in the middle, actually, because it talked about graph neural networks, and it was before the LLMs came out, so the middle section is a little bit off, but the rest of it I still 100% stand by. And the concluding point of that is that as we kind of rush into this new future at 100 miles an hour, we want to think very, very carefully about what we want it to look like on the other side of this, because everything's happening so fast, and we want to be really intentional about the architecture that we lay down into this. And I think it's one of the reasons it's really important that organizations do get on with the job of consolidating their information, because one possibility is that actually we just see like a massive wipeout of all the companies, and like just a few massive data black holes of like suck all the information into them and then dole intelligence back out to us. That would seem, there's quite a few ways that this could go dark, and I think there's kind of an opportunity by people engaging with, like, working out what the ontology of their organization is, what the core of their organization is, by connecting their information together, then they're expressing agency through that, I think, and that's going to be really important.
Where can people find out, or where can people find your Embracing Complexity theory?
It's on Medium. So yeah, if you do like Tony Seale Medium, then yeah.
Okay. And yeah, thanks very much, Tony. What other resources are available? Where can people find you?
So yeah, you find me on LinkedIn. So I sort of post regularly there on LinkedIn with my kind of observations about stuff. You could look up the Knowledge Graph guys, where we do the consultancy where we're helping organizations that are wanting to do knowledge graphs. There's also the academy, where we have two fantastic trainers, pretty soon actually, but two fantastic trainers, Katerina Carley in Europe and Jessica Talisman in the USA, who we run a course there for people who are interested in this technology and want to get themselves to scratch from people, but real people you can trust.
Great. Thank you very much, Tony. It's been a pleasure to speak to you. Very interesting session. I hope people look you up.
Thank you.